Very good morning to all. Today we are going to study about register organization. So before going into the register organization, just a brief idea what we have discussed in the previous session. We have discussed about the internal architecture of 8086. So as we have seen, the internal architecture of 8086 comprises two blocks. The first block is BIU, the second block is EU. In the BIU, full form is Bus Interface Unit. EU, full form is Execution Unit. The main functionality of BIU is fetching the instructions for decoding and executing. Fetching the instructions from the memory depending upon the physical address calculated by this adder. It fetches the instructions from the memory into a queue which is a 6-byte long. It prefetches the instructions while the process is going on, which is the pipelining processes. So it prefetches the instructions one by one from queue. 1 byte of data is being, 2 bytes of data is being stored into the control system, which decodes it into a machine understandable language, which consists of zeros and ones. Then it knows what you need to do and does the arithmetic or logical operations or any operations in the arithmetic and logic unit and stores the data in the present registers and flag registers. See here we have also ES, CS, SS and DS, nothing but extra segment, score segment, stack segment, data segment. These four are the memory segment registers. Getting a point here? Memory segment registers. They are not the memory. They are only, it stores or it has the address of the extra segment present in the memory. See, the segments are being present in the memory. ES register will be storing the address of the, or I can call the starting address of the extra segment in the memory. Similarly, code segment, the starting address of the code which is to be begin in the memory. Segment address is also the address which present in the memory. DS is also a register which stores the address of the data present in your memory. And IP, nothing but instruction pointer, it is called as offset address. These are the physical addresses and this is offset address of the code segment. Like that we have some offset address like SP, BP, SIDI. We'll be discussing in the registers. Okay, so whatever the output arithmetic and logic unit performs will be stored in these registers. So from this registers it fetches the address in order to calculate the physical address, go to that address, take the instructions with the help of a control bus, store into the instruction queue, fetches the instructions, control system decodes the information, decodes the instructions into a machine understandable language, and arithmetic and logic unit performs the operations and the output is being stored into the registers. Okay, this is how your internal architecture of 8086 performs. This is what we have studied in the previous session. Now today we are going for the registers. So what is a register? Basically it is a storage element. Getting a point here? Register, nothing but a storage element. 8086 microprocessor has 4 16-bit registers in an overall. 4 16-bit registers. What are those registers? Namely, the first one is the general purpose registers. General purpose registers. Next is segment registers. What we have seen in our here. These are the segment registers. These are the general purpose registers. And coming to the third, we have pointer and index registers. These are the pointer and index registers. And the fourth one is flag registers. Flag registers. So 4 registers we have in the 8086 processor. They are general purpose registers, segment registers, pointer and index registers, and the fourth one is flag registers. We are going to see in detail about these registers. Overall thing is we have these registers are used for storing the data. So all 4 are 16-bit registers, so you can able to store 16-bit of data into it. Clear? So first, general purpose registers. See, so all the general purpose registers, we have 4 general purpose registers, which are accumulator, base register, count register, data register. Accumulator, first register, base register, count register, data register. These 4 are general purpose registers. These 4 are 16-bit registers. These 16-bit registers can be split into 2 8-bit registers. 2 8-bit registers. So in one register you can able to store the 8 bits, other register you can able to store 8 bits. Overall it is a 16-bit register which are being splitted into 2 8-bit registers. Preferably first will be lower, then it will go for higher. Getting a point here? If you want to store a 10-bit register, 8 bits will be stored in your AL and 2 bits will be stored in your AH. Getting a point here? Right. So lower byte is indicated with L, higher byte will be indicated with H. So these registers can either store the data. These general purpose registers can be able to store the data, variables, it can be able to store variables, and the results, the outputs can also be stored into this general purpose registers. Okay, so the first general purpose register is accumulator register. So what is the purpose of these registers? So as we all know, they can able to store the data, they can able to store the variables, they can able to store the outputs of arithmetic or logical operations or any string operations or any operations, right? What is the purpose? So AX, it is termed as AX, accumulator register, nothing but in a whole, it can be able to store 2 bytes of information, nothing but 1 word, right? So purpose of this one is it can able to perform a 16-bit multiplication, division, or any other input or output operations depending upon, or I can call as input and output operations for a word. 2-byte information. 2-byte can be multiplied, can be summed, can be divided, or any other operations you want to do with that 16-bit. That is the purpose of the register. It can able to store the information as well. It can do the operation as well. Right? So as we all know, AX is being splitted into two 8-bit register, nothing but a byte register. AL lower byte register, AH higher byte register. They can able to do a similar operation what accumulator can do. Overview, it is able to perform IO operations, input or output operations, as well as they can able to store, they can able to do string manipulations as well. Right? So this is the purpose of AX, nothing but accumulator general purpose registers. Next, BX, which is base address. BX, base address. Sorry, base register. Base register. What is the use? It can able to store the address information. The address information. It can able to store the address information, nothing but the starting base address, of a memory location within a data segment. Okay, so we have segments, which is data segment. So in that data segments, what is the starting address of the memory location in the data segment? We can able to store that address information into BX. So again, it can able to split into two different 8-bit information, which is nothing but 1 byte information, BL, BH. Getting a point? Now, coming to the third general purpose register is CX. Its operation is counter register. So counter, nothing but it will count the number of loops we are executing in our program. Getting a point here? It can able to store the number of loop operations, counting operations for string and loop operations. Getting a point here? For string and loop instructions, we will be having the number of loops. That information will be stored into the CX. So for counting purposes, for counting information, this CX is being used. Similarly, CL, CX, CL, CH, and the last DX, nothing but data register. Data register is nothing but it can able to also 16-bit. So we can able to indicate the port address in the IO operations. Okay, it indicates the port address of the IO operations. It can be used as a, it can able to do word multiply, it can able to do word divide, it can be do indirect IO operations as well. Nothing but taking the data from the memory, use it and again store in the memory. That is indirect. Getting a point here? Okay. So we can able to use this DX and AX combined as 32-bit register, because both are 16-bit and can be able to do the same operations. So for multiply, if two 16-bit registers are being multiplied, you get as 32-bit instructions. So for that to be stored, we need to use AX and DX. Getting a point? So these are the four general purpose registers: AX, BX, CX, DX. AX accumulator, BX base register, CX counter register, DX data register.